Hello everyone. Today I'll be explaining you about min-max algorithm. In min-max algorithm, the worst case for maximum value is equal to minus infinity and the worst case value for minimum is equal to infinity. And the best case for maximum value is equal to infinity and the best case for minimum value is equal to minus infinity. But here we will take worst case situation. So we can have max case or min case. So it depends on the type of questions they ask you. Suppose if they ask you just the values with the tree or only the values without the specification of the type of case to be used, do consider the max case as this is being followed popularly. So the max case looks something like this. That is, it starts from the root node. That is, in max case, the root node is considered as maximum and the consequent next level is considered as minimum and the next level is considered as maximum, and it goes on alternating starting from max min and so on. And the second is the min case. The min case starts with the root node as the minimum and the next case next level goes on like max min and so on. So it starts with the minimum and ends with min max and so on. So this is a typical example of the min max algorithm. That is the problem given to us, and the values considered here are -2, 2, 1, 1, 3, 4, -1, 1, 0, 2, 5 and 6. So here what we have to do is just the values will be given and we need to draw it according to a tree structure. So it starts with the root node. If we consider the problem as the max case, then obviously it starts with the root node as the maximum and the next node as the minimum and the next node as the maximum, and it goes on. So the tree is structured as follows. This is the step 1. And coming towards the step 2, we need to consider the max case. For example, step 2 considers the worst case of maximum value is equal to minus infinity and minimum value is equal to infinity. So as we have max case for this level, so max value is equal to minus infinity. So each and every node values has to be compared with the minus infinity. So here as we can see that max of -2 comma minus infinity gives you -2. So the maximum value here is -2. And the next is also applicable with comparison of the next node value with the minus infinity value. So it gives you 2. So the next value is compared with the minus infinity value and that gives you 1. So ultimately we need to consider the maximum of all three values and it gives you 2. That is max of -2, 2 and 1. Among these the maximum value is 2. And similar to this step, we need to follow the same step for all these set of nodes as an independent set. So it applies as follows. So the second set of nodes are as follows. The maximum of 1 is compared with the max of 1 comma minus infinity gives you 1 and the max of 3 comma minus infinity gives you 3 and so on, and we have to group all these values together as the maximum value is 4 here. In this case it's 1 and in this case the maximum value is 6. Once after finding all the maximum values, we have to rename these nodes as with the maximum values. So once after getting the maximum values, the next level to be performed is the minimum case. For the next level, which is the minimum case, worst case for minimum value is equal to infinity. So according to the below structure, here the below tree shows that these are the maximum values obtained from these set of values and these are the minimum values. So what has to be done is each value has to be compared with infinity. So minimum of infinity comma 2 gives you 2, which is obviously the minimum value, and minimum of infinity comma 4 gives you 4. So ultimately, after grouping these together, the minimum of 2 comma 4 is equal to 2. So the same applies for these set of values also. The minimum of 1 comma infinity gives you, obviously it's 1, since 1 is minimum. So the min of 6 comma infinity gives you 6. So which is shown here. Min of infinity comma 1 is equal to 1 and min of infinity comma 6 is equal to 6. So once after grouping these, we come to know that min of 1 comma 6 is equal to 1. So for the next level, which is the max case, as I already told you that initially while we are drawing the tree, it needs to be named, if we consider max case, it needs to be named as max, min, max. Max comes first, then min comes second, and max comes third, and so on. It keeps on alternating. When you consider a minimum case, it starts with the minimum. The root node is named as min, and the next node is max, and the next node is min, and it goes on alternating until it ends. Here the next level is to find the max. So min of infinity comma 2 is equal to 2, which is the maximum value, and max of minus infinity comma 1 is equal to 1, which is the maximum value. So once we group these two together to find the maximum, so max of 2 comma 1 gives you 2, which is the ultimate final tree, once after renaming all the nodes with its respective values. So this is all about min-max algorithm. But there are also some of the demerits or the disadvantages of min-max algorithm, which is as follows. We need to check each and every child of a node to find either min or max value. If there are 10 childs of a particular node, to overcome this disadvantage, we use alpha beta pruning algorithm. The main demerit of min-max algorithm is, suppose if there are n nodes, each n node needs to be compared with either the minimum case or the maximum case, that is either with minus infinity or plus infinity, or either infinity, which becomes a problem. So this creates a complex structure, and this also might take more processing time. So due to this disadvantage, we move on to alpha beta pruning algorithm. These are the most important steps needs to be considered while solving the alpha beta pruning algorithm, the examples. So the steps to be followed are as follows. That is, the first step is the alpha denotes the maximum value. In worst case, alpha is equal to minus infinity, and beta denotes the minimum value. That is, in worst case, beta is equal to infinity. At maximum level, we will change value of alpha. So the beta value remains constant. At min level, we will change value of beta. Alpha value will remain constant. So the fifth step is the most important step to solve the alpha beta pruning algorithm problems. So as the example shows, the values of alpha and beta can be taken downwards. That is, the values can be straightaway moved downwards, but it cannot be retraced or cannot be taken upwards. While an individual is solving the problem, one must not forget to check the condition. That is, in each step, try and check whether the alpha is greater than or equal to beta. As it has already been explained in min-max algorithm, if one considers the minimum case, then the root node must be started with the minimum, and it goes on alternating like min-max, and so on. Then if one considers this is the min case and this is the max case, if one considers the max case, then the root node starts with the max and it goes on as min, max, and so on. This is an example which shows how to solve an alpha beta pruning problem using depth first search approach. It is also very important to remember that if one encounters a maximum case, then the only parameter which changes is the alpha and beta remains constant. So in max case, alpha keeps changing, whereas beta remains constant. And in the min case, this is the max case and this is the min case. So in min case, alpha is kept as constant and beta keeps varying. That is, beta changes its value. From this example, we observe that the nodes are numbered as 2, 3, 5, 9, 0, 7, 4, 2, 1, 5, 6, and this is the tree structure. Using depth first search approach, one has to remember during solving alpha beta pruning algorithm problem, as it traces the path from the root node until the leaf node and considers the value by comparing it with the minus infinity. So for max case, the initial value of alpha is equal to minus infinity and the initial value of beta is equal to infinity. So as I already discussed, in max case, the alpha keeps varying. That is, the value of alpha keeps changing and the beta remains constant. So in min case, the alpha remains a constant and the beta value keeps changing. So let us start solving the problem. First, moving on to node E. At node E, as it is a maximum level, initial value of alpha is equal to minus infinity, but it will change in the maximum value. Max case, initial value of beta is equal to infinity, it will remain as constant. So maximum of minus infinity comma 2 gives you 2, that is the maximum value is 2 at node E. So once we get this maximum value, this value is compared with the other value for maximum. So the max of 2 comma 3 is equal to 3. So the node E is renamed with the value of 3. So moving on to node B. So at node B, the initial values of alpha and beta are equal to alpha is equal to minus infinity and beta is equal to infinity. So the value value 3 is moved from node E to node B. Then this value is initialized to beta. So since the node B has another node attached to it, so it needs to check the values for this node also. So as we have discussed in the important steps, so the values can be passed from a top node to the bottom, whereas the values cannot be retracked or passed back from bottom node to top node. So here alpha is equal to minus infinity and beta, as it takes value 3, is moved on to node F. So here we need to consider the max case. In this case, in max case, whatever happens, beta remains constant, whereas alpha changes. So here 5 is compared with minus infinity. So as we know that 5 is maximum, so minus infinity is cancelled and renamed as 5. So alpha takes the value 5. But in order to decide the value of B, since there are some changes made here, so we need to compare the values of E and F for minimum. Since the upper case, that is the top nodes, is of min case, so 3 and 5 needs to be compared for minimum. So which according to these both, 3 is the minimum value. So the value doesn't change, it remains as it is. One more important rule that we discussed earlier was to check whether alpha is greater than or equal to beta. According to this scenario, once alpha attains the value 5, it needs to be compared, whereas 5 is greater than 3. So once this condition is satisfied, the corresponding nodes, that is the nodes attached to the current node, is not taken into consideration, or the exploration of the other nodes can be stopped. So the other nodes may be not considered for the decision of the maximum value. So we skip the other nodes once this alpha is greater than or equal to beta condition is satisfied. So here as we see that beta takes the value 3. So for minimum we name it as less than or equal to 3, and for maximum we name it as greater than or equal to 3 in all other cases also. So here the value 3 is moved on to the top layer, which is the max case. So here alpha and beta takes the default values as minus infinity and beta is equal to infinity. So here as it is maximum, alpha keeps changing but beta remains constant. So 3 is assigned to the alpha value. So here the root node A is assigned with 3. So once after A attains 3, alpha value is equal to 3 and beta is equal to infinity. So this value can be passed on to the corresponding nodes. So since all the changes I've already done here, so the next nodes which are attached to A are C and D. So C takes the value that is alpha is equal to 3 and beta is equal to infinity. Same we copy it here for our future reference. Alpha is equal to 3 and beta is equal to infinity. Then these nodes can be also passed on to the other nodes which are attached to the current node. As alpha is equal to 3 and beta is equal to infinity. Then alpha is equal to 3 and beta is equal to infinity. So since G is attached to only 0, node 0, so it needs to be taken into consideration. That is, since it is max, we consider it as greater than or equal to 0. So once the value 0 is passed on to the above layers, that is beta takes the value 0, and as we know that alpha remains as it is because in minimum case only the beta value varies. So the ultimate goal is that we need to consider an important rule, that is alpha is greater than or equal to beta. So here the condition satisfies, that is 3 is greater than or equal to 0. That is 3 is greater than 0. So we cancel out all other connected nodes. So no need to explore these nodes as well. So we move on to the above step. So since A is attached to D, we have to move to these steps also. So as we have already discussed that alpha as 3 and beta as infinity can be also passed on to the corresponding nodes. And here the value, as we have already discussed here, since the values 2 and 1 exist in this corresponding node, then we need to consider the maximum case, that is which are the maximum among these two. Maximum value is 2 by comparing it with minus infinity, as we have already discussed. Minus infinity comma 2 gives you the maximum as 2. So 2 is compared with 1, which is maximum 2. So we consider it as greater than or equal to 2. And this value 2 is passed on to the above node. So it attains the value. Since it is minimum, we make it as less than or equal to 2. Since D is attached to the other nodes, node structure, we need to consider this as well. Before considering this structure, we need to figure out one more rule, that is an important rule which we have followed in all these nodes as well. That is alpha is greater than or equal to beta. This is an important formula to be remembered in order to solve the alpha beta pruning problem. So since alpha is equal to 3 and beta takes the value which is passed on from the below node, that is beta attains 2, 3 is greater than 2. So this node can be eliminated, or this node structure might be prohibited from exploring. So from this example, all these values are the minimum values. That is 3 is minimum for node B, 0 and 3 here. So in order to decide the root node's value, we need to compare which is the maximum among these three. Since root node is attached to max case, we need to consider which is the max case. So comparing 3, 0 and 3, obviously we come to know that since it might repeat, but we need to consider it as 1, so the maximum value is 3. Hence we have solved the alpha beta pruning problem completely. The below text shows a typical steps to be followed in solving the alpha beta pruning problem, which may be noted down as well. Now the next part of alpha beta pruning problem is to find the alpha beta cutoff. So the alpha beta cutoff can be calculated as follows. One has to keep in mind that when you're not trying to explore a set of nodes, then the main node which is disconnected only needs to be connected to calculate the cutoff, whereas the sub nodes cannot be used to calculate the cutoff. So according to this example, the alpha cutoff is equal to 1 as follows. Since we have only one node which is not considered for exploration, so since it is max, so this is considered as alpha cutoff, which is 1, and the beta cutoff is as follows. The minimum cutoff, that is, as you can see that we have cutoff here and here, but these need not be considered. It should not be considered actually. So the main nodes which are disconnected and which are not being considered for exploring for min and max values. So according to this example, the minimum, that is the beta cutoff, is equal to 2, that is 1 and 2. Here it's just 1, and here we are not considering two structures. That's all for alpha beta cutoff. Thank you for watching this video. Hope you liked this video. In today's agenda, we have studied how to calculate the min-max algorithm problem. And this is the min-max algorithm tree structure, which is the final tree obtained by solving and by applying the min-max algorithm. And this is the alpha beta pruning problem. And this is the final tree obtained by applying the concepts and the important steps of alpha beta pruning. And the alpha beta cutoff obtained is equal to 1, that is for alpha is equal to 1 and beta is equal to 2. Thank you for watching this video.